Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 22, 2025, about 4 days ago. The big idea is a Retrieval-Augmented Multiview Diffusion pipeline that pulls real web images for a prompt and conditions generation on them, which markedly improves 3D consistency, photorealism, and text adherence for out-of-distribution and rare concepts. The paper is titled MV-RAG, Retrieval-Augmented Multiview Diffusion. And as we will see later, the results are really impressive. Beyond the core method, the study introduces a rigorous out-of-distribution evaluation set and shows competitive performance on standard benchmarks while surpassing prior text to 3D, image to 3D, and personalization approaches on challenging cases. Also, the authors shared a GitHub repo. It includes a ready-to-run MV-RAG pipeline with main scripts, a multi-view diffusion pipeline, retriever modules, utility code, and an assets example. You get Conda setup steps, requirements, Hugging Face weights, a simple run command, and pointers to benchmarks and citations. Alright, the intro just highlighted the goal and the code release. Figure 1 illustrates the core workflow and contrast. The left panels show text prompts with retrieved real-world images, which then guide multi-view generations that stay consistent across viewpoints. The right panels depict a plain text to multi-view baseline that misses rare concepts, so shapes drift or simplify. The comparison matters because retrieval supplies concrete visual evidence that anchors the diffusion prior when the prompt names out-of-distribution objects. So figure 2 shows the retrieval-augmented pipeline in action. The system retrieves web images for the prompt, encodes them with a frozen image encoder, and passes compact tokens through a resampler that feeds retrieval attention modules inside the multi-view UNet, camera poses, and a three-dimensional self-attention block coordinate views, so the network generates a consistent stack of views that match the prompt while respecting the retrieved appearance cues, while the prior pipeline view set up the components. Figure 3 shows the hybrid training scheme that alternates between a three-dimensional mode and a two-dimensional mode, so the network learns both geometry and retrieval conditioning. The left panel renders ground truth multi-view images, applies heavy augmentations as pseudo-retrievals, and supplies camera poses with the prompt. The right panel pulls K+1 real images from a web corpus, predicts the held-out view, and swaps in two-dimensional self-attention because no camera poses are given. This pairing teaches 3D consistency from structured data and from unposed in the wild imagery. So the training setup just established why retrieval signals matter. Table 1 presents quantitative results on out-of-distribution prompts across 4 views and re-rendered evaluations, which compare text to 3D, image to 3D, and 3D personalization baselines. MV-RAG achieves the best or tied scores on most metrics, including the top CLIP similarity, the lowest FID, and the strongest multi-view consistency, so the method reproduces rare concepts more faithfully. The consistency gains persist after 3D reconstruction, which indicates that the multi-view outputs align well enough to form a coherent object. Wrapping up, 2 takeaways stand out. Retrieval-conditioned multi-view diffusion fixes rare concept failures by anchoring generations to real images, and the hybrid 2-dimensional plus 3-dimensional training enforces stronger geometry and view consistency. The broader implication is scalable text to 3D that generalizes beyond benchmarks. That is it for the AI Research Roundup. I am Alex. Thanks for listening.